Hey guys, so welcome to my C/C++ tutorial series. In this video, we will finally start writing some code. Now, I'm going to structure this video in a different format. That being said, is I'm going to jump between different stages, sometimes a top level overview, and sometimes an in-depth overview. And I will strictly try to reduce my work. So I will just tell you that you can search this and download this, and you should probably be able to download it or find some YouTube videos how to search or download it. That being said, there is not too much things to download, but let's start with the first C/C++ program today. So how we would write a C/C++ program is through a source file. Now you can use a notepad, you can use VS Code, you can use any kind of software to do it. I'm just using NeoVim for the sake of simplicity and the kind of aesthetics that I prefer. But you can use anything. And also the extensions to some extent doesn't really matter. But for general, you use something called .cpp as your source files extensions to denote that these are C++ programs. Now, C++ can be thought of as a superset of C. That being said, there are some differences between C and C++. We will come to it. This is strictly C++ and also covering the concepts of C. So, yeah. So, first of all, you need to create this kind of files to write your programs with .c or .cpp extensions, depending on whether you are using C or C++. But .cpp handles both. So, let's go for .cpp and yeah, let's create this file. Now, once you have this file, what you would additionally need is a compiler, as we talked in the previous video, to compile your program. Now, there are multiple compilers. Like I'm naming some of them. Like if you are on a Windows operating system, you will probably like to install Visual Studio. I would recommend using Visual Studio if you are starting to write programs and you're using a Windows environment, because Visual Studio in Windows environment just makes sense. Okay, if you are starting to program, but if you are not into big sizes of files or stuffs like that, then probably you should use Clang. You can download them. Clang is provided by LLVM. Okay, you will go to their website and download and basically. And the third choice will be GCC GNU. If you are on a like this is for Windows. Okay, for Linux, my first choice will be probably Clang. You can just install Clang there. And if you don't have Clang, if you don't want to install Clang, then Linux distros come with GCC and G++. Okay, GCC/G++ for Linux programs. Now, how to use Visual Studio, how to use these kind of things. You can even use in, like there is a version of IntelliJ also for and like Eclipse for C++ program also. So the choice of program is up to you, I guess. I will be just doing it in a minimal way. So once you have these things, you can essentially write a code, and then you can use these tools to compile your code and get an executable file. Now I will be compiling with Visual Studio. Once you have Visual Studio installed and you have like you can just go to the editor and click the and start debugging or something like that button to like debug and work with your code. For now, I will be just using the command line tool that Visual Studio provides that is CL, I think. So let's start with the first program. First, let's write our program and then I will explain to you what is going on. So I will starting by including standard library. and then I will like something like int main. I will put two parentheses here. I will return a value like 0, and here I will like two. Let's say I have two integers. One is centigrade and one is Fahrenheit. So I have centigrade. Let's say C is equals to, let's say I have 30 degrees centigrade, for example here, and I want to know the equivalent Fahrenheit value for that variable. So the formula for now, this is called a comment, and basically after double slashes, whatever you write here is ignored by the compiler. So you can write your own uh, good things here that the compiler will just ignore. So my single line comment, for example, or you can like write multiple lines by using this and then like ending like this. Okay, and this stars are optional, but here you, whatever you are writing is going to be ignored by your compiler. Okay, so I call it my multi-line and so on. So that I will go to comments when the time comes. But for now, let's revise the formula that we have the centi C2F formula. And if I remember, that is C by 5 is equals to our F minus 32 by 9. Okay. So given a C, how can I get the F value? It's very simple. If you do some maths, so the F will be equals to C times 9 by 5, because 9 comes to the other side of the equation, and then because this is minus 32, it will be plus 32. So that is what, and that's what I'm just going to write here, that int F is equals to C times 9 by 5 plus 32, and then I will say printf, and I will write something like this. Okay. I will probably like avoid this, and for now I will say printf centigrade. I don't remember it. Yeah, like this. So I have centigrade, and then I have the Fahrenheit. Let's call it F. Okay, I don't want to like write the wrong spellings. Okay, I'm not a native. So that's a simple program. So I will explain everything here in a bit, but this is suppose code in C++, let's say. Okay, and now what I want to do is I want to save this file probably, and I will call CL, my compiler, whatever you are using. In case of you are using GCC, you just say GCC. Or if you are using Clang, then you will say just Clang plus plus. Or if you are using GCC, you will say G plus plus. Okay. So, for example, I will say CL, and then I will give my first app's name. So, first dot cpp. And what it will do, it will try to compile this, and it will show me some errors. So let me just see. Yeah, it should be CSTDIO. Okay, I will explain to it. But once you do that and you check into the repo or the directory, you can see two files. One is your .obj file, if you are using like Windows, and one is your .exe file if you are using Windows, and it will be like .out file if you're using Linux, a.out or something like that. And what this is basically your executable file. So now if I try to execute this file, you can click on that file to execute it also. If you're on Windows, they are not that much strict. So you get something like this. Okay, 30 degrees centigrade is approximately equals to 86 degrees Fahrenheit. Okay. So what just went here? And also, like if you're using G++, it's just the same. You just say G++. I don't know if I have installed it. Most probably I will have. I don't have it. I have Clang, I think. Clang plus cpp. And it should also like produce the first dot executable file. In this case, it will be the Clang one. So I can execute it, and it's also the same. For Linux distros, however, I think G++ is available, so we can go to my Ubuntu that is installed here. I guess it will take some time to load. It actually loaded. So just let's say uh, same way vim first dot cpp, and here I will do something similar. I will say hash include stdio, and then I will have int main, and I will write, let's say, printf hello world backslash n, close it, and then I will say return 0. And now if I say g plus plus first dot pp and I run it, we will see that here is a dot out file. If I run that a dot out file, we will see that it says hello world. Okay. So two different programs, but I just wrote this one so that you can actually have something to work with after your first tutorial if you're new to it. So what's going on here? So let me explain you. Every C and C++ program starts with a function from where the code starts executing, and you declare it. Okay, like here, when you are, and a function is written as this. You use a type. Okay, and int is nothing but says that I am trying to use a integer. Integer means that it's a whole number, and whatever the function is, it must return that value. So in case my main function is of type integer, I am defining it, and so my main function should return an integer. That is this last line. It's 0. And in case of C and C++, your code is executed from the top to bottom, right? And who is running this main function, you may ask? It's going to be run by your operating system. Okay. Your operating system knows that when I'm trying to execute this executable file, the point that I'm going to start execution is going to be main. That being said, main is not the only execution point. In Windows, you have also win main, and you can also like define your own execution point if you want. We can come to that in a later video. But the idea is that every C or C++ program usually must contain one and only one start point, and that is called int main. And you define a function by providing this two curly braces, and whatever you write in between them is going to be executed one after another. So this is a function. Okay, I can write another function, like for example this I will come to it. And every time you try to use some placeholder for something, it might be a string or a text, it might be a number, it might be a whole number. In case of here, int means a whole number, or it might be a different type of data. You start by declaring it as an data type. It's called int here. We will look into data types in the next videos. But for now, just for the basic syntax, you define a type by calling int. Okay. If you want an integer, if you want a character, you say char. But for now, let's just focus on int. Okay. So you define a value by defining its type first. Then you give it a name. This name, whatever you want, it can be multiple letters. It need not be single letter. But the only and it can also have underscore. The only restriction is it cannot have symbols like at the rate, and it cannot have uh, a number at the beginning. Okay, number can at the end is valid. You cannot have a number at the beginning. Okay, and these things we call them as symbols. Okay, like this main is also a symbol. Okay, whatever is in green here, you can see in my highlighting, whatever is the green here, these are keywords. Okay, like in this case this is a data type, but these are also keywords. There are some reserved words in the C++ library that are available there to have different functionalities. Some might give you some ability to execute some conditions. Some might give you some ability to run the same code again and again and again. Some might give you some other kind of functionality, like defining what kind of data you are trying to use. But statically, C or C++ being a compiled language, and most compiled language being a statically typed language, every declaration must start with the definition of what kind of value is stored there. Okay. If you have no value stored there, then you can say void. Void means that nothing is there. Right? In that case, I don't need to return zero. Now main is a special function, so even if you use int and you don't return zero, your compiler is smart enough to guess that it will be returning zero. So returning zero in case of main is not required. Now you declare a variable like this. You can just declare a variable like this, int apple, and let's say I have 5 apples. Now, every statement in C++ must end with a semicolon. If you don't give the variable a particular value before trying to query the variable, it will assign a random value to it. Okay, whatever value, whatever place in the RAM the variable was created. When we will talk about variables, we will talk that space, whatever value was written there, when you are trying to access that variable, it will be given to you. So before you use your variable, always assign it a value. You can assign it after declaring your variable, or you can assign it when you are declaring that variable. Okay. Now, the next thing is that there is no such limitations that how many variables you can declare. So keep on, like, actually there is a declaration, but like a limit, but like you're not going to like run over it most likely. So like here, this nothing but this statement says that I am declaring a variable called C, and I am assigning it a value of 30. And how do I assign a value? By using equal signs. The same way I am saying that I am declaring a variable called f, which is an integer. Integer means it's a whole number. And what I want to do is I want to get the value, whatever it was, whatever, and I want to use this operation on this value. That is, I want to have the value of C, multiply it with with 9, divide it by 5, and then add 32 with it, and then I close my statement. Every statement in C++ or C must end with a semicolon, and then I need to show that output to the screen, like what the value of C was and what the value of F was. So for that I used a function called printf. Like when I in that Linux version, I said printf, you remember, and I said that hello world, right? So printf does not create a new line, but it just prints to the console or the screen or the command prompt, whatever you are using, and you go to a next line by saying backslash n. So this backslash n is a special character. It's not treated as backslash n, but it's treated as a new line. So I want to go to the next line. So here also you can see that I want to say that printf, whatever C and then equals to, then whatever the value I had in C, because it's an integer, printf uses something called as a formatted string, and everything that is inside double quotations, we call them as a C string. Okay. So this is a C string, that is the printf's first argument, and whatever you pass inside a function is called as its argument. Like this main function is called by your operating system. Called means nothing but executing that function. Here, printf was defined somewhere else, and that somewhere is here. This cstdio, this is called a header file. Header files, they essentially contain definition of different functions that in your program you can include by saying hash include, and which allows you to basically copy and paste whatever was inside that file in your code, so that your compiler has, your program has the definition of that thing. Like this stdio, it has the definition of the function called printf that is going to show something on your screen. In this case, it will going to first show hello world, then it is going to show c equals to, and then I need to put a value here, which is a variable. Now I cannot like put a like if I just write c here, for example, it is a it is a part of the string, so there is no way to learn know for the printf key whether this is a value or something else or just a character c. So for that distinguishing, what people who implemented printf did is, as like they defined backslash n as a special character for new line, they defined these placeholder formatted strings, these are called format strings, to particularly specify kind of data type that I am going to put here. For example, here I am saying that c equals to percentile d, and percentile d is saying that here a integer is given, and then giving the comma, I am providing the second argument. Whatever you give to a function is called an argument, that is c. Okay. In the same way, if I'm right saying here key for f, I am giving another argument, that is f equals to, and then here my put my integer here, and then go to a new line, and here I am putting f. Now if I want to put them together, printf is a special function, so it takes a variable number of arguments. So I can just say the printf, and here I can say that c equals to percentile d, this is my first variable, and f equals to percentile d, which is my second variable, and both of the type integer. Whenever you declare a variable, you provide a type in front of it, and then I provide c and f. Okay, so here it will put c and f in the same line, and then I provide c and f. So if I run this code, first I compile it. So I will say that cl this, and then I will just directly say to execute it, because why not? So using this is, you can use concurrent operations one after another if you are using command prompt. Unfortunately, this doesn't allow us because I am using PowerShell right now, which is somewhat good, somewhat bad, I don't know. But this you will have, like, whenever you install Visual Studio, you will have developers command prompt or developers PowerShell there, so you can use it. So here I have a typing mistake, and this is what is my compiler is written. You read these statements to understand that what went wrong. Like here it's saying that at line number 19 you accidentally misspelled printf, which is not anywhere defined. So I will fix that issue. I will I will go to the file, and instead of writing printf here, I will say printf. Now these are case sensitives, so you have to maintain the case, and also you cannot start with a number. Remember that. So now that it's corrected, if I compile it, and then I will say I will try to run it, I will say that it's going to say hello world, and followed by it's going to say that c equals to 30 comma f equals to 86, because that's what I wrote in my program. Okay, that is first print hello world, and this, and before that I am calculating f in the value of c. Now, as this main is a function that is executed by the operating system itself, you define it. You can also define other functions there, but remember that your code is executed from top to bottom. So whenever you're using your function, the function must exist before it. Now there are some other ways you can do it, but I want to do is I want to get an integer, and I will call it C2F. Okay, that stands for centigrade to Fahrenheit. Okay, this is a bad way to write it, so I just write C2F, so it makes more sense. Okay, always try to keep your names that makes more sense. And just like before, like how printf takes arguments, we can tell our function that it can also take arguments. The first argument is integer, and we call that integer as my carg. for example. Okay. Now, whatever I write here is only accessible to this function only. Okay. It does not affect the other code that is there. Okay. So you can be sure that whatever if is passed to the function, this is a placeholder. Like for here, I can put 1, 2, 3, 4, 5, but it must be an integer. Now I can directly put 1, 2, 3, 4, 5, or I can put, for example, a variable that I have declared, like here C. So what I can do is I can say that return, because this is an integer function, it must return an integer. I will say return, and in this case, if I stop doing typos, I will say C argument times this formula. First, that's what this function does. So now here, instead of using this, I can just say that C to F C, and I can also have another int F2, and I can call it C to F20 for 20 degrees centigrade. Now I will put this at the top. Okay, sorry, I will put this in the top. So I have first, if let's call it F20, and let's call it FC. Okay, so this is I am using for C and FC, and then I want to do the same thing, but in this case I want to show for 20 and F20. Okay. So now I don't have to write the code again and again. I just encapsulated the code into its own function, which takes the argument whatever I need to pass here, and here that carg is 20, and here that carg is, for example, C, and whatever the value of C is right now when this line is executed, that is going to be passed here. In this case it will be 30. Okay. And this is when you are defining a function. There are two parts of a function. The first is the definition, how the function acts, and that is you provide a type for that, or that function will is of type. For now we know only one type, that is integer. It is a whole number, and that's why the fractional parts are not there. And then you give it a name, and then you give it an arguments. You might need some additional arguments. You might not need some additional arguments. Like in this case, our main does not need any argument from outside, so that's why it's empty. Here I need one argument, so it's there. If I want another argument, I can give there. Like for example, if I want to write an addition function, I will just say int add. It will take an int a, an int b, and it will return a plus b as the addition. And then, like in curly braces, you give the definition. First, you need to define a function. Once your function is defined, then in anywhere in your code, you can use that function by providing it the values for the argument. Okay? The values might be directly these things. It's called literal. It's an int literal because it is an integer value, or it might be a variable. Okay, in this case. And then also there are libraries that you can take help of by including them. Here I have included one such library called cstdio, and then by including that I got the ability to use a function called printf that can print out something that I provide to it in the screen, and that something is called a string. Now in that string I can also add different values. For example, if I need to include an integer in that string, what I can do is rather than typing that integer directly, I can put a placeholder here called %d, and this %d means that this is a integer. And then you can use how many what you want, and then you provide the corresponding values in the same serial order after that. This is how the printf function is designed. This function can take multiple arguments. That is a little bit advanced topic. We will cover it in the future. But this is how basically you can write your own program. Okay, now if I uh, try to compile this, and then if I try to, let's say, run this, you see that C is 30. For that, the Fahrenheit value is 86, and when C is 20, the Fahrenheit value is 68. Okay, so this is your first example where you can have a complex mathematical equation, uh, and you can just execute it. Okay. I will give you another example here, and before we close that thing, and I will delete all this stuff, and we will start writing from scratch so that you can understand. I will say hash include and I will include CSTDIO. STDIO stands for standard input output. Okay, name makes sense, and that's why. And then I will define my entry point, that is main. This is the function that will be executed by your operating system when you are going to click on that executable file, or you are going to call that executable file from your command prompt or whatever terminal you are using. And then you can simply write printf function that is provided by this library, so that you can print to the screen, and you can add different arguments there. uh, for a new line you use backslash n. For giving a particular value you say percentile d if it's an integer. And let's do it this time. We are going to convert degrees into radians. So once again I am going to define our function degree to radian. Now, this kind of declaration of a name is called camel case. Yeah, camel case, where you have the first letter as small, but like keep a declaration consistent. It makes you like keep track of it. So I provide it a degree, and as you can see that a degree is multiplied with the value of pi and divided by 180 to get the radian. Now this is, you can see, this is a floating point number. Floating point number is defined as float. Okay, and also like my degree can also be a floating point number. I can say float. What a float allows you is where int is a whole number, a float is a decimal number. That means it can have fractional parts. Okay, decimal number with fractional parts. So this time degree to radians will uh, have that fractional part there. So now we can simply say that I have let's say 90 degree, and how many radians it is, for example. Okay, or I have 30 degree. So int my value is equals to, let's say, 30.5 degrees. Okay, because it's a floating point number. A good way to do it is writing dot f here. For now you are beginner, like for the beginning we can just go with it. And for printing a floating point number you say percentile f. For integer it was percentile d, for floating point number it's percentile f. Okay, and so we can say that my my radians for 30.5 degree is this. And then I can also directly call this function here, or I can do this, or I can do one more thing is I can say that int let's say my value 2 is equals to let's say 10.2 degrees, for example. And I can also say that my radians, uh, and I will probably call these floats. Okay, so these are floating point values. Also, it will work with int. It will just strip that floating that decimal point after it. Actually, I don't want to do that this time. And I can also say that float my output is equals to, I will call that function my degree to radians, and I'll provide it the argument that is my value, like that, and it will give me the output. So I can also say that I can write that my radians for let's say let's give here percentile d for our float. Let's say percentile f. Sorry, where did I go? Here. So I say percentile f degrees, and then I will just add some kind of arrow here. And if you don't put this backslash n, then it will not go into the next line. And then I can put it here. Or if I am more fancy, then I can also say like my radians for 20.243 0.32 degrees is nothing but my whatever the function calculates give me here. And here I can directly say that degrees to radian, this value. Okay, this will be 20.34. And now if I run this program, I'll be compiling it first. Okay, it's saying some error. Format string %f requires argument double, but v is an integer. So it's an error because what happened is somehow I this is returning a floating point value, but I put it an integer. So this degree to radian here, it returned a floating point value. Uh, it returned an integer value instead of floating point value. So that's where the problem came. The problem did not caused by this line because it was defined as float. So the decimal value after it was stripped and it was converted into an int. But when this int was passed here and I tried to print it as a float, it encountered an error. So the simplest fix will be, because we are using all floating point numbers here, you can say that just my function returns a float, and that will basically solve the issue. So now if I run this after compiling, okay, it's saying another that printf not enough arguments passed to format string, and this error is returning from line number 15. So you can come here once again to see that at line number 15 what went wrong. And if I go to one line number 15, you can see that I have passed this thing, okay, and then I have called my value. Okay, but yeah, like this one is line number 15. So what happened is that I said that I will provide two floating point numbers, but I provided only the output, that is this number, but I never provided the first number. So I need to provide the first number also. I will say my value, and then I will provide my output. Okay, so if I do that, and obviously this will be my value 2. Okay, because the output was computed from my value 2 here. I just decided to do it right now. And so now it's saying that my value 2 is undeclared. Why it's saying that? Let's check it out. So we can see that I have spelled here that VAU2, and here I have forgotten to put the L, but in the later spaces I have used the L all the time. So I also need to keep the names same in order to the compiler to understand that okay, this is what it means, and don't do this kind of typos. As you can see, the compiler is smart enough to understand all the kinds of error that I am causing. It's still not happy with me yet. So VALUE, it's not VAULE, so VALUE. Now that my value 2 is there, these other my value 2s, they actually make sense. Okay, so this also my value 2 is makes sense. So now if I compile it, you can see that it's compiled successfully because this has outputted the fast.exe file. So now if I run this fast.exe, you can see that my radians for 20.34 degrees is 0.355000, and for 10.0 to 10.2000 degrees it's 0.17, and so on. Now another tip for if you are not interested in showing multiple decimal places but only two decimal places, what you can do is in front of this percentile, after this percentile, in front of this two, you can put a point two. That means I want to show up to two decimal places in case of floating points. This will not work with the integers, so don't put it there, because integers don't make any sense to have floating like points after decimal points, so it will not make sense. So if I just fix this small issue and also just put a space between here so that they look clean. And now if I run this, because I want to show to it two decimal places, what it will happen is first I will compile this and then I will run my program, and you can see that it's now showing into up to two decimal places. So that's it for this video. Hope this gives you a basic understanding, very basic understanding of how you write a program in C++ or C, and how you use that to like calculate or compute whatever is your desired thing. In this case, I wanted to compute degrees to radian for these two and this one value, the 20.434. So thank you guys. In the next video, we will talk in depth about the types, that is this int, float, and stuff like that, and also the variables that these things. And in the upcoming video, we will talk about some other things, and then we will revisit our functions and we'll know more about functions, and we'll keep on learning much more things, much more interesting things. And when those things exhaust, we will probably keep on learning different libraries. When those things exhaust, we will keep on learning different, how you implement different kind of things, and so on. Like learning never ends. Okay, I am still learning. You will be still learning after like 10 to 20 years. The learning never ends here. Okay, so that's it for today, guys. I hope you enjoyed this small video. In next video, we will in depth talk about memory and variables and data types. So till then, bye. And also, if you like my video, give a like or subscribe to my channel. And where is that stop button? Come, my mouse. And where is my mouse? That is also a question that I want to get somehow sorted. Then I don't find my mouse pointer for some reason. Ah, yeah, here